Hey guys, welcome back to my CCNA 20301 course. Patrice is here, and in this video we are going to cover one of our first CCNA topics, compare TCP to UDP. Are you ready? Let's get started. Before we jump onto our main topic, we need to review some key facts about TCP/IP. First of all, TCP/IP is a protocol suite, as we mentioned before, and it includes lots of protocols. These protocols are defined in different RFCs, or request for comments. RFCs are basically detailed documents about different protocols, and you can find them on IETF's website at this address. IETF, or Internet Engineering Task Force, is the organization that is responsible for TCP/IP standards. And finally, IANA, or Internet Assigned Numbers Authority, is responsible for assigning IP addresses around the world, as well as TCP and UDP ports, which we will talk about them later in next slides. As I mentioned in the previous video, transport layer is a critical layer, and its role is pretty delicate. The functions that are defined in transport layer are connection establishment and termination, sequencing data transfer, multiplexing, error recovery, and flow control. Let's discuss about these functions. When I was talking about the data flow in the networks, I told you we add and remove headers in the encapsulation and de-encapsulation processes. These are two headers that you can see them here. One is for TCP, this is for TCP, and this is for UDP. As far as you can see, TCP has got more fields in its header, and you will figure it out why soon. Basically, we got two different types of communications in the networks: connection-oriented and connection-less. Long story short, connection-oriented communications rely on TCP and connection-less ones rely on UDP. But when we use TCP and when we use UDP, when we need reliability, which means the correct delivery of the data, we use TCP because TCP is able to do that. But when we need speed, we use connection-less communications. If I want to give you an example, connection-oriented communications are, for example, for mail or email delivery. It is not acceptable to have a half email. All of your email data should be transferred. But in VoIP or voice or video over IP communications, it doesn't matter if something is pixelated or a sound just drops within a long communication or long conversation between two ends, and it is acceptable. Connection-oriented communications start with a connection establishment process. For this purpose, the starter sends a packet with SYN flag set. TCP header has got 6 flags. Each of them is 1 bit. Sending a packet with SYN flag set has got a meaning, and it means, hi there, I want to make a communication with you. Are you ready? And if the destination is ready, it responds with SYN and ACK fields set. This means, yes, I'm ready to make a communication with you. And finally, the starter again sends a packet with ACK flag set. And this means, okay, so we start our communication. As you can see, this is a 3 stages process. So it is called 3-way handshaking. And after this, both ends are ready to transfer data. When the data transfer is completed between the two hosts, they terminate the connection. There could be some other reasons for connection termination as well. To terminate a connection, the starter sends a packet with ACK and FIN flags set. This means, hi there, I want to terminate this connection. Are you ready? And the destination responds with 2 packets in a row. First one with AG flag set, and the other one is with AG and FIN flags set. And finally, the starter again sends a packet with AG flag set. This means that this connection is terminated now. Among all functions that I've mentioned for transport layer, multiplexing is the only one that is common between TCP and UDP. In TCP/IP terminology, basically, multiplexing means sending and receiving different flows of data over a single medium. And it has been implemented through the concept of port numbers. If you go back to the slide that I showed you TCP and UDP headers, you will find out both of them have got source port and destination port fields in their headers. But what is this port? This port is basically a number that segregates different services. Let me demonstrate it on the slide. Most of you have got a modem or router at home, and this router has got a single connection to the service provider. If you got an advanced router that has got a failover connection over 4G or something like that, I don't want to talk about it. Let's assume that we've just got one communication to the service provider, and we connect to the internet through that service. And the rest of the world also connect through their own service providers to the internet. Let's assume that I open a web browser in my computer, which is tabular these days, and I open two different tabs in my browser. One of them is going to Google website, and the other one is going to Yahoo's website. And we know that they actually host on different web servers over the internet. But the thing is, for example, both of the sites use port number 80, which belongs to HTTP protocol. Although practically they are all on HTTPS or port 443. It's just an example. Okay, it never happened to you that you see the content of Yahoo web page in the other tab you opened here, and vice versa. And how does it happen? There's no any interference between the data flow you do to the Yahoo's website and the Google's website. This is the multiplexing feature that helps us to segregate these different data. How? You saw that we got source port and destination port fields in our headers in TCP and UDP. So when we want to send the traffic, for example, to Google's website, we say our source port number is 1024. There are some predefined port numbers that I'll show you in a tick. And the destination port is, for example, 80. And for the other flow, we say the port number, source port number is 1025 and destination port is 80. Just say, doesn't matter. We got two different source ports for our flows. So this will segregate this traffic from this traffic. Source port and destination port fields are 16 bits. So their value could be between 0 to 65,535. Yana is divided this range into three different categories. The first one is well-known ports, which is between 0 to 1023. It is strictly observed by Yana because basically this range is used for services and servers need to have these ports opened. The next range is user or registered ports, which is between 1024 to 49151. And we normally use this range in source port field to segregate different flows. And finally, the ephemeral port or dynamic ports, which is between 49152 to 65,535. And this range is used temporarily for client applications that are running on a computer. The next three functions, which are error recovery, sequencing, and flow control, are kind of correlated. So I demonstrate them all together. In the connection establishment process, one of the items that two hosts are agreed is a parameter which is called window size. And this value is set in the window field of TCP header. What does it mean, or what is it for? Window size is the number of packets or segments that the sender can send without receiving the acknowledgement. Why do we need the acknowledgement? The acknowledgement is for error recovery process. So let's assume that the agreement between the two computers is 3000 bytes of data. Computer A, which is the sender, will send the first segment, which is for example 1000. And this value is set in the sequence number field. The next segment is sequenced to 1000. And the next one is sequenced 3000. This is sequencing and sending the data in order. First 1000, then 2000, then 3000. And now we have reached the window size. So the sender will stop to receive the acknowledgement. The acknowledgement field is a 32-bit field, just like the sequence number, as you saw it in the slide. The acknowledgement field determines the next segment sequence number. So acknowledgement 4000 means, sender, please send me the segment that has got the 4000 sequence number. With receiving this acknowledge, computer A receives a confirmation that 1000, 2000, and 3000 have been received. So now it's turned to send 4000. But what would happen if, for example, 2000 hasn't been received in the destination? In this circumstance, computer B in the acknowledgement process will send 2000. This means that computer A, I haven't received 2000 and you have to resend it. So computer A will send a packet which has got sequence 2000 and will be waiting for the next acknowledgement because it reaches the window size. And if this 2000 receives at the destination, this time, the destination or computer B sends a packet with acknowledge 4000 now. And now computer A will send sequence 4000, sequence 5000, and sequence 6000. And it waits again for next acknowledgement, which should be ACK equals 7000. This is how error recovery and sequencing works. But what is the flow control? Flow control is actually completely depends on the window size. And this window size can increase and decrease in a communication period. And I'm 100% sure that you saw this before. When you download a file, you saw that your download speed increases and decreases over time because the window size changes continuously over communication. And it completely depends on the capacity of both ends, including the processing capacity, internet capacity, and other stuff. Now is the quiz time. Which of the following functions is common between TCP and UDP? Connection establishment and termination, sequencing data transfer, multiplexing, error recovery, or flow control? And you're right, the answer is multiplexing. Alright guys, this was our today's video. If you enjoyed it, please do not forget to subscribe to the channel, like the video, and put your comments down below. Thanks for watching.